Hello and welcome to the first session of this FDP. So we'll be taking an overview of industrial IoT. What do you mean by industrial Internet of Things? So I have divided this particular session into multiple parts. So in the first part, we'll introduce with the IoT, and then we'll go through the concepts of IoT's architecture, the things that it contains, and in the prime focus that we are going to have it on industrial Internet of Things. What are the different angles that by which we look from the industrial IoT there. Okay, so let's start with this. First of all, what do you mean by IoT? So, Internet of Things is a network of physical objects or things embedded with electronics, software, sensors, and the network connectivity which enables this object to collect and exchange the data. A perfect definition where uh, the embedding of all these things, okay, what we call this electronics or software, sensors, network connectivity, these are the things we connect them with the help of the internet. And what are the why we connect them? Because of when to collect the data, we have to exchange the data, we have to create a communication network among all. So IoT is a network by which you connect every non-living and living things together. They will communicate with each other, they will get connect with each other, they will collect the data from each other, and then they can control each other also. This is what IoT is. So IoT objects allow to be sensed, controlled remotely across the existing network infrastructure, creating opportunities for the direct communication integration between the physical world and the computer based systems, and resulting in improved efficiency, accuracy, as well as the economic benefits. These are the prime advantages that we can take out from the IoT by improving the efficiency, accuracy of the results, as well as the benefit in terms of the economies, because the human efforts are reduced, the number of employees that we are going to have there, that will be reduced. We'll be creating an automated system, so automation system is created. So with the help of that, IoT can result efficiency, accuracy, and the benefit in terms of financial. Okay, so what do you mean by things? So things in the IoT sense can refer to a wide variety of devices such as heart monitoring implants, biochip transporters from animals, electric lamps on coastal waters, automobiles which are having inbuilt sensors inside, DNA analysis devices for environmental or food pathogen monitoring, or field operation devices that assist the firefighters in search and rescue operations. So almost everywhere, thing considers everything which may be electronic device, electrical device, automobile device, or it may be a natural device or natural things which is created by nature. Okay, so all these can be the part of IoT. These devices collect useful data with the help of various existing technologies and then autonomously flow the data between the other devices. And that data collection is done by automated systems. So we need to create these infrastructures in the IoT. With the help of that, data exchange, data control, data communications will be possible. Now, basically, when this IoT was created, the concept of this network of smart devices was discussed as early as in 1982 for first time. Okay, with the modified Coke vending machine at the CME, that is Carnegie Mellon University, becoming the first internet connected appliance able to report the inventory whether newly loaded drinks were cold or not. Okay, it's very interesting that 1982, first time that Coke vending machine was containing the activity of internet IoT. Now basically, see, internet doesn't mean that we are going to have the world wide web connected to it. World Wide Web started in the year 1990s. Okay, before 8 years ago, 1982, internet, that is interconnected network, was used to control a machine. Okay, so it was reporting the things like inventory, how much Coke's bottles are present in that, and whether they are cold or whether they are hot. So based on that, the reporting was done. So the first example, but actual concept of IoT, where we are going to make use of World Wide Web within it, became popular in 1999. Okay, so through the Auto ID Center at MIT, related to market analysis publications, and the most important part that IoT started with the commonly used device like radio frequency identification, that is RFID. Today also, RFID forming the base of communication among many devices which in the IoT. okay, was seen as a prerequisite for the IoT at that point. If all objects and people in daily life were equipped with identifiers, computers would manage and inventor them. Okay, so that's what means. See, whenever we need to communicate among the devices, every devices, living and non-living, we must have to provide a unique identification to them. That unique identification will facilitate our communication among the devices. Okay, obviously. So if you consider a computer network, in computer network also, if all computers are same, then also everyone is having a unique identification. That is what we call as IP address. And with the help of that IP address, we communicate among the computers. So that IP address or that unique identification is most important in this particular network design in terms of IoT. Okay, so besides RFID, the tagging of the things may be achieved through technologies like NFC, near field communication, barcodes or QR codes, Bluetooth, digital watermarking. So many ways are there by which we communicate this, and that communication will be taken through these network areas, and controlling communication, analyzing collections. All these operations will be done easily with the help of an IoT application design here. Now, how it works basically. So IoT is not a result of a single novel technology. It's instead several complementary technical development provide capabilities that that taken together help to bridge the gap between the virtual and the physical world. These capabilities are like that: communication and the cooperation, addressability, identification, sensing, actuation, embedding, information processing, localization, and user interfaces. Now, let's go one by one how IoT actually works. Communication and cooperation. So, this is the brain, this is the heart of the IoT device over here. Communication and the cooperation. So, basically, without communication among the things, IoT does not exist. Communication is compulsory. So, a multiple ways. In previous slide also I shown that whether we can use the NFC communication, RFID communication, or making use of any Wi-Fi communication device, or a Bluetooth device. So any one of this can be used. Cooperation means I'll send data to other things, that thing will send data to me, and then we'll decide what action to take. Like addressability. So addressability and identification, they are almost connected to each other. So we must be capable of addressing an element in the network. If you are using a Bluetooth device, your addressability can be different. If you're using Ethernet or Wi-Fi, addressability is different. RFID addressability is different. So how addresses are given, that's different. But it must contain the ability to have an address and unique identification device over there. And then identification, okay, which will be identified based on the unique address assigned to the respective device there. Then sensing, basically sensors are the input devices in many cases in IoT devices. Sensors, for example, why sensors are required? Sensors converts human identifications into the computer identification systems. We know the temperature of this room is something 30 degree here. Okay, I know that, but how computer will know the temperature of this room is 30 degree? So we require a sensor. Computer will know the human identification entities with the help of the sensors. Sensors are the electronic devices which used to perform this sensing of the data, sensing of the entity, and then IoT device will consider an action or will generate an action, and that action will be used further for automation in the IoT. Sensing is required. Actuation is like taking an action based on that. Okay, so if, for example, in a room, I'm creating a room control device. It means that if room of the temperature of the room is going below certain degree, then automatically your AC should start. So AC should start is an action. That's an actuation, and sensor will send the temperature. For example, the temperature is going above 30 degree. Your AC should start. So sensor will sense the temperature, will report to the actuator, and then actuator will take the action by performing this action, by performing this operation, like making or starting the AC on, starting the ACs. Okay, that's what we are going to have actuations. Action can be given in any form, like starting an electrical appliance, or showing in the form of a light, or generating some buzzers like sound. So any output, actuation is the output that IoT performs. Then embedded information processing. So in this we are going to have make use of some systems like cloud computing. Some clouds can be used where information can be stored, that can be processed, that can be analyzed, and based on that the future predictions are done. That's what we call as the embedded information processing. So embedded information processing can also be done with the help of the IoT. And in the localization is very important. That localization means you are going to make use of this IoT system in a particular area we develop, but whether we have developed for that particular uh, area, that particular system or not, that is when we deploy the IoT system, that must be compatible with the area where we deployed that. As for localization, and the most important is user interfaces. User interfaces means the user can have the control of it. It's not a whole automated system. User can have a dashboard, user can have a control mechanism, user can have a GUI, graphical user interface. With the help of this particular graphical user interface, he will control it, he will monitor it, he can generate an manual action also. Based on that, he can see that how IoT device works, how accurately it works, how what are the benefits you are getting out of it, and whether all the living and non-living things are connected together to collaborate or to create a collaborative system among all. Okay, that's how this IoT system actually works with the help of all these things. So these things you need to remember when IoT is actually created in the systems. Okay. Okay, so this is the last slide of this first session. Let's see how exactly it works. These are the four common layers that IoT is containing here. What are the four layers? So as I told already, sensors are the input devices in many IoT systems. So here we have the sensors. They are used to collect the data. They are used to convert the human identifiable entity into the computer identifiable entity. That's what we call as sensors. So lot many sensors are there. I'll show the sensors in some of the slides here, and in upcoming sessions of IoT also we are going to see make use of the sensors perfectly. Okay, IoT is input device. Okay, so by which we can sense temperature, we can sense speed, we can sense the touch, we can sense the smell, we can sense anything, any human identifiable entity can be sensed by sensors. Collect the data, then connectivity, so we connect with the help of any network applications. But we are told already this they are used to send the data to the cloud. Okay, cloud means you're going to collect the data at central locations. Okay, that's what we are sending the data to the cloud. Then data processing, we process that data, making that data useful. We extract that data, we mine the data. We can apply any data science, data mining, machine learning, we go over them on that, and based on that we're going to deliver this information to the final user interface. That's what we have, the user interface here. Okay, so delivering information to the user will be done with the help of this. So user can see what exactly is happening within this particular systems. So these are the common layers, these are the common four layers IoT systems are actually containing. So where we start, sensors will collect the data, will send this data through an connectivity mechanism to the data processing center. So that's what we call as the cloud, where data will be collected, or not compulsory that every data collection center should have a cloud present over there. Data can be collected by any mechanism, so you just can collect it there, collector, and then after we are going to make an user interface by which you can see what exactly happening inside the IoT system that we created. Okay, so here this interface can analyze, can monitor, can communicate, and can control this IoT system also easily. That's why this interface mechanism also very important. Most of the time in today's world, user interface is given as facility by IoT as a service. So many clouds are now created, they are providing IoT as a service where user interface is customized. So they have provided dashboard to you, you have to customize that dashboard, and based on the customized dashboard we need to create your IoT system application over there. Okay, so this is from the first session. In next session we'll continue with the IoT further. Thank you, thanks a lot.